Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Technogenier. In today's topic, we will study the basic concept of HVDC transmission line. So, what is HVDC? HVDC is high voltage DC transmission. So, if you see the diagram, you will see that we have thermal power generation or any other power station. These power stations usually produce AC supply, and this AC supply is then transmitted to a rectifier which will convert AC into DC. And normally this DC is an high voltage DC, and then we have a special infrastructure for HVDC transmission, and it will be transmitted through that infrastructure and to the distribution end, and then the distribution end will convert DC supply into AC, and then it will be this AC supply is delivered to the residential area. So in this lecture we will study the basic definition of some important terminologies which are used in HVDC system, then introduction of HVDC system, what is HVDC transmission line, different types of HVDC transmission line which are monopolar arrangement, bipolar and arrangement or homopolar arrangement, then comparison between HVDC and HVAC system, and then the advantage of HVDC system and disadvantages of HVDC system. So there are some terminologies which we will use in this lecture, so we need to be clear on that terminologies. First is converter. So converter is, by definition, it is a machine or a device which convert AC to DC or DC to AC. The second is rectifier. So rectifier is a device which convert AC supply into DC. Third one is inverter. An inverter is a device which convert DC supply into AC. And the fourth one is reactor, an inductive reactor between the DC output of the converter and the load. It is used to smooth the ripples in DC to reduce harmonics in voltage and currents in the DC line. So now introduction of HVDC. HVDC is basically an high voltage DC transmission. In if you see in the previous systems which are normally used are AC transmission system, but if you see the DC transmission system, the DC transmission system is an economical system, and it is better as compared to AC system because there are many losses in the AC system due to the frequency, while in the DC system the losses are minimized. So it is preferable for long distance overhead transmission line. It is also used in underwater or underground transmission line. And third most important advantage of HVDC system is that it does not require any synchronization, while in the AC system without synchronization we cannot combine two or more supplies in a system. So the DC transmission line was initiated in Sweden in 1954, but the wider application of HVDC started in 1960. HVDC system, the AC voltage is in HVDC system, the AC voltage is rectified and a DC transmission line transmit the energy, and then the inverter will convert the DC voltage into AC and it is transmitted to the residential areas. So there are three different topologies which are used for HVDC transmission line. The first one is monopolar arrangement. Monopolar arrangement means that we are using two conductors for HVDC transmission. One is for the positive supply and the second one is for the negative or the ground supply. So the positive supply, the main current will be passed through the positive supply, while the ground terminal will give a closed loop or closed circuitry. So there are two possibilities to use monopolar arrangement. One is that we do not use a ground cable, and the other one is that we are using a ground cable with the help of a special conductor. If you see the diagram, that these are the two topologies of monopolar. One is that we have an AC system, we rectify the AC system, then we can convert the DC supply into AC by using inverter, and then we have the load receiving and AC system which is connected to the load. If you see, there is no wire, no ground wire between these two ends from the input till the output. The input and the ground wire of the input end is grounded, and similarly the ground wire of the output end is also grounded. So there is a virtual ground wire in between the transmission end and the receiving end. Another topology is that we use a ground terminal. The remaining is same. We have the AC power, which is rectifier, then it is transmitted, then we have inverter, and then we have the load. But we need an extra wire or the conductor between the input side and the output side for the ground. So these are the two topologies which are used for monopolar arrangement. The second type is bipolar arrangement. Usually in bipolar arrangement we use two different supplies. So the ground terminal is common from the two supplies. We have positive input and the second positive input. So the neutral terminal is grounded. If both the currents are balanced, then balance means that in the first circuit and the second circuit the current is balanced, then it will cancel its effect, and the ground, there is no current in the ground circuit. If you see this diagram, you will understand that we have two different supplies, and then for these two different supplies we have rectifier and inverters which will convert these AC into DC and then DC into AC. At the receiving end we will get the AC input for our load. But we if you see that there is two different supplies which are used to transmit this one, so the power will be doubled. But if you see that this ground is ground in the input, is ground in the input side, similarly it is ground in the output side. So in between the input and the output side there is a virtual ground. So we should consider this thing in mind, that if the system is balanced, that means the above side of the transmission line and the lower side of the transmission line, the current is same, then it will cancel its effect, and then there is no current which is travel in the ground line. Bipolar HVDC system. So if you see that we have one transmission line over here, the second transmission line over here, and these are the generator 1 and generator 2, then we have the converter transformer, then we have surge arrestor, then we have the converter. If you see, there are two converter, one is converter transformer and the second one is converter. So converter transformer is basically a transformer which will step up the input side of the system. So these transformer are usually connected in a AC side, and it will use to step up the voltage of the system. The second thing is surge arrestor. You already studied the surge arrestor, that whenever surge occurs it will become short circuit so that the fault do not penetrate into the system. The third one is the converter. So converter, we are using converter to convert AC supply into DC supply. And then we have reactors. Reactors are used to remove the harmonics and smoothen the wave of the DC system. Then we have surge arrestor, then we have complete transmission line. In the receiving end, initially we have surge arrestor, then DC filter, then DC reactor, then converter, surge arrestor, converter transformer, and then shunt capacitor or AC or series capacitors that are used to remove the harmonics in the current and the voltage. So this is a complete block diagram of a bipolar arrangement of a HVDC transmission line. So the third type is homopolar arrangement. Homopolar means that if we use two or more than two poles, like in bipolar we use two poles, but if we use two or more than two poles all having the same polarity, then it is called homopolar system. So in homopolar system, we transmit more power as compared to the bipolar system. but the DC tower normally carry only two insulated conductor, and the ground return can be used as an additional conductor. So we will prefer the bipolar system rather than we going to the homopolar system. Now the comparison between an AC system and the AC DC system. One thing you should make clear in that we need to assume something in order to compare this AC system into DC system. So initial assumption is that the both lines have the same length and are made up of same conductor size, and the loading of the both line in the thermal limited, so that the current equal to the DC current is equal to the AC current. As the load and the system are same, so the DC current is AC current. While for the AC system we need to do further assumption that the power factor of the system is 0.945, and for the DC line a bipolar circuit arrangement with two conductors is developed. The third most important point is that the AC and DC insulator withstand the same crust voltage to the ground, so that the voltage and the DC is equal to 2 times RMS voltage of the AC. Because if you see the system, we are using two separate circuits in connected together, so we need the voltage is 2 times the voltage of. Therefore, it can be shown that the DC power is PDC is equal to voltage DC into current DC, while the AC power is voltage line to neutral voltage into current into cos theta. So cos theta is basically the power factor. Therefore, the ratio of the DC power conductor to the AC power conductor can be expressed as PDC over PAC. So the DC power is this one and the AC power is this one. So these ratio are shown. So in order to solve this one, we just need the under root 2 factor, that is basically the RMS value. So if we cancel each and everything, then the ratio would be PDC over PAC is equal to under root 2 times cos phi. Now so if we solve this thing, if we put the value of the cos theta is 0.945 and under root 2, if we solve this thing, then it will be 1.5. For PAC in a single phase phenomena, but we are using two circuits for the DC, so the DC power is 2 times PDC, and for the AC we use 3 phase, so the DC AC power is 3 times PAC. So the ratio between PDC and PAC is 2 by 3 into PDC over PAC. But if we choose these two equation, number one is this one 6.9 and the second one is 6.5, so we can combine these two equations, then we have 2 by 3 into 3 by 2 is equal to 1. That means that if we use two bipolar system, then the power of the DC and the power of the AC are equally transmitted. Now both lines have the same transmission capability and can transmit the same amount of power. The DC link has 2 conductors rather than 3, thus require only 2/3 as many as insulator. If you see that for the AC we use 3 phases, so for the 3 phases we transmit the 3 wires. For the DC we had practically we do not have any phases, but we use 2 different supplies to connect it. So practically we need at least 2 conductors. So for the AC we have 3 conductors, for the DC we have 2 conductors, so it is a cost effective solution. Therefore the requirement for the tower and the right of the way are narrow as of DC as compared to the AC. Even though the power loss per conductor is same for both lines, the total power loss of the DC line is only 2/3 that of the AC. If you see the basic thing, that for the AC system we are using 3 wires, for the DC system we are using 2 wires. So the if you need to check the overall power loss, then it would be 2 by 3rd of the AC power. Now, this is an important thing is that for the DC, the cost is almost 33% less than the AC system to be installed, because the tower structure is different, wires are different, and the losses are minimized. So the HVDC system is much more better than HVAC system. If a two-pole DC line is compared with the double circuit three-phase AC line, the DC line cost would be amount is 45% less than the AC. So if we have a single circuit, then we have 33%. If we have double circuit, then it will be given advantage of 45% less cost. So the cost advantage of the DC line increase the higher voltage. So if we need to take the advantage of the cost, then the voltage should be higher than and then voltage should be higher in HVDC system, because if the voltage is low, then HVDC system is not feasible. So the power loss due to the corona phenomena are smallest for the DC system. So if we need to calculate the capacitance of the system, then it is XCV square. So when we put the value of XC, it is omega CV square. While when we use the inductive value, it is XLI square. So if we open these equations, we will see that for a system when there is just a resistive load, so we need to cancel the capacitive and the inductive effect. So this effect is known as surge impedance loading SIL. So if we compare QC is equal to QL, then we have omega V square is equal to omega L I square. So if we cancel the major parameters which are similar, then we have V square is equal to L. V square is equal to I square. The remaining value is ZC is equal to V over I. So however, if we calculate, then ZC is equal to under root 2 times under root L over C. So this L over C means that the conductive and the reactive power, the reactive power that is from the capacitors or from the inductors are similar. So this phenomena is also known as surge impedance loading. That means that when we have XC and XL, both are equal. So for the SIL, that is we have V square over X ZC. इसको आप इस तरह भी समझो कि जो सिल है वो बेसिकली ये चीज़ बता रहा है कि जो आपके सिस्टम में कैपेसिटिव इफेक्ट ज़्यादा है या इंडक्टिव इफेक्ट ज़्यादा है. अगर हमारे सिस्टम में कैपेसिटिव इफेक्ट ज़्यादा होगा तो जो इनपुट करंट है, इनपुट वोल्टेज जो है वो आउटपुट वोल्टेज से कम हो जाएगा. अगर मेरे सिस्टम में इंडक्टिव लोड ज़्यादा है तो जो इनपुट वोल्टेज है वो आउटपुट वोल्टेज से ज़्यादा होगा. तो ये चीज़ को आपको अंडरस्टैंड करनी है कि जो सिल है उसकी मिनिमम वैल्यू को हमने यूज़ करना है ताकि ये सेल वाली प्रॉब्लम ना क्रिएट हो. So it is surge impedance loading is a function of voltage and the current, voltage and line inductance and the capacitance. In general, the economical load of the given overhead transmission line is larger than cell. So it is very important that the load should be larger than cell. The cost of the necessary series capacitor and shunt reactor compensation should be taken into account in comparison of the AC and DC. The DC line itself does not require any reactive power. However, the converter at the both end of the line require reactive power for the AC system. Secondly, when we are using underground cable, then the DC system is much more useful as compared to the AC system, because in the DC system there is no chance of the capacitance or the inductance effect, while in the AC system this effect appears, and this factors give losses to the system. The second most important part is that we are using submarines or underground cable. AC cables are also always operated at a load that is far less than the surge impedance loading in order to prevent overheating. So if it is not prevented, then there is a chance to catch fire or some problems may occur. Thus, the compensation shunt are to be provided at a regular interval. Contrary, DC cable do not have such restriction. Thus, the power transmission using DC cable is much cheaper than using AC cables. Now, the advantage of HVDC. The major advantage of HVDC is that HVDC is comparatively lesser or less expensive as compared to HVAC. But there are some limitation. If the length of the transmission line is less than 500 miles, then HVDC is not useful. So the threshold value is 500 mile. We should have 500 mile or more than 500 mile. Somewhere between 15 to 30 miles for submarine and 60 miles for underground. So we have three different standards. If we want to install overhead transmission line, then the length should be greater than 500 miles. Otherwise it is useless. Second thing is, if we want to use this transmission line in submarines, then it should be 15 to 30 miles. While if we want to use it for the underground cable, then it would be 30 to 60 miles. So DC link, another advantage of the DC link is that it is an asynchronous system, so there is no need for synchronization. So it is an extra benefit or advantage of an HVDC system. The third most important point is that the corona loss in HVDC is minimum as compared to the corona loss in HVAC system. Then the power factor in HVDC system, the power factor is usually unity, while in HVAC system it depends on the load. If the load is greater, then the power factor also gives some impact. The interconnection of two separate AC system via DC link does not increase the short circuit capacity. Thus, the circuit breaker rating of either system should be okay or above. The last most important point is that the line losses in is smaller than the line losses in the other transmission line. Now the disadvantages of HVDC. The converter generate harmonic voltage and harmonic current on both AC and DC side. As you know that we use special type of MOSFETs or a special type of MOSFETs or IGBTs to switch on or off the system and produce a pure sinusoidal wave. But in these systems, then where we have a huge capacity of inverters and converters, but these produces voltage harmonics or current harmonics. So in order to avoid this voltage or current harmonic, we need a special system to filter out these things. So the converter consume reactive power. The DC converter situations are expensive, and DC circuit breaker have disadvantage with respect to the AC circuit breaker, because the DC does not increase to zero twice a cycle, contrary to the AC. So for the AC we need special kind of circuit breaker and dependent on the voltage level. For the DC, we can say that the DC does not require a huge number of inverters or breakers. But thank you, Jazakallah. Hopefully you will understand the basic concept of HVDC and the advantage or benefit of the HVDC system. Jazakallah.